In this demo, I want to show Orbital combining some data from some microservices and a database. We'll apply a caching layer and then publish our integration as a REST endpoint, which takes a customer's account number as a parameter. We'll do it without having to write any glue code, simply using a few taxi specs to describe our data sources and a TaxiQL query to power our integration. So let's get going. Okay, so to get started, I'm just going to pop into a browser and go to start.orbitalhq.com. And that gives me a Docker Compose file that I can use to bring up the whole stack. So I'll just copy that and paste it into a new file here in VS Code, compose.yaml, paste it and save it, and then run Docker Compose up-d to bring up the stack. After a few moments in a browser, I'm going to head to localhost 9022, and that'll bring up Orbital. So we've got an empty Orbital workspace here. So the first thing I'm going to want to do is pull in the code for this demo project. So I'm going to go into projects, add a project, and we're going to add a project from a Git repository. Now, this code is up on GitHub in the Orbital API demos project. So I'll just copy that URL and click test connection. Everything looks happy. Now, this project, this GitHub repo has a bunch of different projects in it. And the one we're interested in for this demo is this one here, microservices DB cache. So I'm just going to copy the path of that into Orbital and click create. And Orbital's going to go and clone that project, pull it down from Git, and in a moment we should see it appear here. So there's my project. And it's also going to spin up all of the different services that we need for this project. So in this instance, it's going to be creating a Hazelcast cache, a couple of microservices, and a database. Now, this is just for demo code. Normally, you would have your own services that you're actually integrating. But because this is a demo project, Orbital is set up to wire up these stub services on startup. So if we click on stub services, we can see what it's done. If this is the first time that you're spinning up Orbital, this stage can take a little bit of time just while we're pulling down the different Docker containers that we need. But once everything's up and running, we should see some healthy stub services and we can browse our project. So our project README has all of the kind of key information that we need to know about this demo. So starting off with this diagram of our key services. So if we blow that up, we can see what it is that we're working with. So these are a few different services that we have in a pretend bank situation. So Orbital has these nice diagrams that we can kind of explore the different services and data that's available. And they're interactive. So for example, here I can click to see what comes back from our account service. And I can see that our account service here gives me back an account. And we can see how the data from the account relates to other different services. So the ID that's coming out of our account. So we've got our database that's giving us an account model here. And the ID from that can be passed into this transaction service to give us a list of transactions or account balances. Likewise, the customer ID that's coming out of our accounts database can be fed into a different database to give us customer data. The other thing that I want to call out here is Orbital has sitting behind it a really nice catalog that's powered by all the different APIs that we publish. So we can click around and have a look at our customer data here, explore the catalog page for our customer, and see how everything kind of hangs together. So we can click on the customer ID and see where that's used across the different systems in our application. So before we dive into writing queries and stitching data together, let's take a quick look at how everything actually works under the hood. So everything inside of Orbital is powered by Taxi, which is a semantic language for describing data and data services. Sitting inside of our project, we've got a handful of Taxi source files. Now, the idea behind Taxi is to describe our data semantically. So inside of this project, we've created a handful of types that just describe ideas that exist across our business: account ID, customer ID, transaction ID, timestamps. These descriptions are really basic. They don't talk about which system has the data. They don't talk about which service to go and talk to fetch the data. You're really just defining concepts. And then inside of our descriptions for our services, we use those same semantic types. It gives us a way of saying, hey, this piece of information is available in this service. It also lets us map out how data between services relates. So here's an accounts database down the bottom, which has a table returning accounts data. And inside the account definition, we've got a handful of columns defined, an account ID, and this is the name of the column, and this is the semantic meaning of the data that's in there, right? So we can see here, it's a type of string, but it's not just any type of string. It is an account ID. It's got a column called customer ID, which is a type of string, but it's not just any old string. It is a customer ID. And we can see that relates down here on our database table for our customer, which also has a customer ID. So we know now that these two columns have the same piece of information. And that's really all Taxi is. It's a way of adding semantics into our descriptions of our data sources. Now, in this demo project, we've actually written out all of our Taxi by hand. Often, you would generate your Taxi by including metadata in your OpenAPI spec or in your protobuf spec or your Avro spec. So you don't always hand code everything, but because we want to show you what's going on in the demo projects, we've written out our Taxi by hand. And it's these definitions, these semantics that let us explore and understand how things relate. It's how we can dive into a customer ID and see how it relates across different objects, because our definitions have the semantics to say, hey, this isn't just any old string, but it is a customer ID. Okay, so now that we've covered off the basics of how we use Taxi to describe our services, let's write some queries to pull the data together. Taxi uses a query language called TaxiQL, which uses the same types and semantics that we've embedded into our service descriptions to ask for data. For example, if I want to pull back a list of accounts, I can just say, find a list of accounts. Orbital looks at the data catalog to find which service has a collection of accounts and pulls the data back for us. Now, TaxiQL lets us reshape and restructure data using consumer contracts. So I can say, hey, restructure the response of the accounts coming back to give me the shape that I want. So I want a field called ID, which is an account ID. And I want a field called customer, which is a customer ID. Now, when I run the query, I just get back the data that I asked for. Let's restrict this down a little bit so that instead of bringing back all the accounts, I'm just bringing back one. We do that by adding in a constraint to the data. So we're saying that instead of giving me any old account, I want an account which has a constraint where the account ID equals ACC1. Now, when I run my query, I get back just the data that I'm looking for. Let's switch this out a little bit. So instead of just the customer ID, we get back an object containing information about the customer. Give me their first name and their last name, as well as their ID. If we look in the raw output here at the JSON, we can see now that we're getting back a customer object that has the name and ID. Now, this requires us to join data from a couple of different tables. If we take a look in the profiler, we can see what's going on. So we can see that we're doing a query against the database to pull back the ID and customer ID fields, and doing a different query to pull back the customer name. Okay, let's flesh this out a little bit more and pull in some spending data. Actually, let's bring in their account balance. Okay, here's the account balance. So we can see the account ID, the balance, and the limit. I'm going to limit this down. So again, I'll define it just with the data that I want. I just want the balance and the limit. There we go. And finally, give me all of the transactions. So I'll ask for a list of transactions. Great. So now we've got some transaction data coming in there. Also, let's add one more thing, add in some spending insights. And here's the data that we've asked for. Okay, I'm pretty happy with this. If we take a look at the profiler and see what's going on, Actually, this integration's gotten pretty complex. So we've got a query going against the database, and then we're feeding in data to a series of different REST API calls to pull together all of the different data that we're looking for. Now, it's important to recognize what we didn't have to do here. We haven't had to write any glue code to say how to stitch these services together. We haven't had to build any GraphQL resolvers to wire up different database calls or wire up different API calls. Really importantly, that means that that's code that we don't have to maintain as our architecture evolves. Okay, I'm happy with this query, so I'm going to save it. Save it to my Insights portal project, and I'll call it spending insights. Great, and I'm going to publish that on an HTTP endpoint. Great, so just a warning here telling us that because we're working with a Git repository, just to remind us to commit these changes and push them back up. Okay, so this data is now available on this endpoint, which if we just copy this as a curl statement, jump into a terminal, and curl it out, and here's my data. So this is stitching together multiple different API calls with a handful of database queries to build out the data that I want to return from my UI. Now, the one problem here is that this is currently hard-coded to this customer, ACC1. So let's parameterize it by sticking it in the endpoint. So we'll say we're going to pass the account ID in, which means that this query now gets a parameter. So it gets a parameter of account ID, which is a type of account ID. That parameter comes as a path variable called account ID. Okay, and finally down here, we just make this a bit more dynamic and change that to equal account ID. I'll save it, get rid of our warnings. And now if I jump back in here, so we can pass our ACC1 into our endpoint. Here's our data coming back for Jimmy, which is great. Let's do it now for ACC2. And we're getting a different set of data back for Jane Splats. Okay, now that we've run our query and we've published it as an endpoint, we've parameterized it. Now I want to add some caching to keep things nice and fast. If we take a look in the stub services that we first deployed, you can see I've got this Hazelcast instance, which is an in-memory data cache available. And we've wired it up. So we have a look in our data sources. We can see it's exposed as a connection that we can use called My Hazelcast. So I'm just going to copy that name. We can jump back into our query editor and add a cache annotation with a connection of My Hazelcast. I'll just save that query, get rid of our warnings. And if we jump back into our command line and hit our endpoint a couple of times. Great. Now, if we have a look in our query history that shows all of the queries that that have been executed by the service, we can take a look at the profile of the most recent one. And we can see that previously we were hitting the different services to load data. Now it's being served out of a cache. So what we've done is we've deployed a Hazelcast cache. Orbital has connected to it, created the maps that it needs, and configured it as a read-through cache. So it's attempting to read the data from the cache. If the data is missing, then it's populating it from the backend service. Now, by default, Orbital honors cache headers that are returned from HTTP services to indicate how long data should be cached for. But you can configure that with TTL annotations on the services. It's quite a complex topic, so we're not going to go into it in this tutorial. Really, what I just wanted to show is how easy it is to start wiring up and using caching. So let's recap. In this video, we took a quick look at Orbital's data catalog and architecture diagrams. We had a flyby of Taxi, our semantic language for describing data sources, and TaxiQL, Taxi's query language. And we wired together a series of services, a couple of database tables, and multiple REST APIs. We parameterized our query and deployed it as a REST endpoint before finally enabling caching. We did all of this without writing any integration code. Not bad, huh? The code for this demo is up on GitHub, and if you have any questions, come chat to us on Slack. Thanks for watching.